Hi guys, good evening everyone. Welcome to the session and welcome to the India's most comprehensive preparation platform, the BYJU'S exam prep. And yes, me Rakesh Talreja once again welcome you to this digital electronics classes. And yes. So I'm so sorry for it. Just a second. Yes, all fine. Okay, yes. So basically, as we all know, today we are going to discuss up the state transition diagram. Yes, guys, you know the state transition diagram of different flip-flops, SR flip-flop, D flip-flop, JK flip-flop and T flip-flop, and also the questions that is expected in the competitive exams like GATE or ESE from the state diagram based area, right? State diagrams of the flip-flop. So let's go into that. Let's start conquering this subject, everybody. Let's start conquering this concept, everybody. Yes guys, so yeah, in case if somebody new to my session, a brief intro about myself. This is your mentor and educator Rakesh. I have secured All India rank 9th in the GATE examination, completed my masters from the Indian Institute of Science, Bangalore, and I've trained more than 50,000 students in my more than 11 years of teaching experience. I commonly deal with control system, digital electronics, signal and system, electromagnetic theory, and in the general I also deal with the maths and aptitude, right? Hall of Fame, guys. Yes, BYJU'S exam prep really outshine in the GATE 2022 results, GATE 2022 examination, having secured All India rank 1, 2, 3, multiple students secured rank under 50 and many students secured rank under 100. Yes guys, so if you want to enroll to BYJU'S exam prep GATE preparation programs, and yes, if you want to get some financial assistance to prove yourself in the scholarship test, yes, BYJU'S exam prep brings you a scholarship test on this Sunday, that is just tomorrow, 1st May at 11 a.m. Right, so appear in the scholarship test and get scholarship up to 90% of the course fees. Right guys? Okay. Yes guys, a quick reminder once again, everybody. Yes, that tonight after this session on the same channel at 10 p.m. we are going to have a session where we'll talk about how to deal with the stress and anxiety in the digital age. Now, we know that most of the students, whether it is GATE preparation or university preparation, it's a digital age, and most of the things we are studying online or we are reading online books, and everything is, mostly digitalized, which is very beneficial. It has its own benefit, but if not handled with care, it may have bad impacts on our health. Yes guys, so what I want is the GATE preparation of the student should be on the very correct track, but also the health should not be compromised. So what are some of the effective tips, scientifically proven tips, okay, to deal with these issues? So if you are facing these issues, let's go through this session. Join me live tonight at 10 p.m. Join me live tonight at 10 p.m. right? Depends. If no need to watch every lecture completely, Navneet, but yes, if there is one or two topic that is disturbing you, that is difficulty, you can watch it up, and that too in the fast forward mode. Maybe you can increase the speed of it, but not everything. Watching it entire lecture will be taking a lot of time, I believe, right? This is what is our series going on to learn the concepts of latches and flip-flop. And yes, today we are at 30th of April studying the state transition diagram. Tomorrow, 1st May, Sunday, this is the entire week's plan, where in Sunday we are going to discuss the questions based on the waveform, some important questions with respect to the competitive examination. Now, let's get started, everybody. Yes, and do not forget meanwhile to share the session to your friends. I see the live attendance not very appreciative towards the end of the classes. This usually keeps on happening, but that's not the good way of studying anything. Okay, Chalo, so do not forget to share the session to your friends, whoever are interested in the Gate 23, Gate 24 preparation. Now guys, state diagram. So whatever we have been discussing for flip-flops right now were either the equation. Which equation? We call it as the state transition equation. Na? Which equation we are talking about? The state transition equation, characteristic equation, next state equation, right? Or in terms of tables, characteristic tables, also known as next state tables, or they finally represented in the form of graphical symbols. But the flip-flops can also be represented graphically by a state diagram. Now, what is the state diagram? How to make the state diagram of all flip-flop, and then not only flip-flop, how to make the state diagram of different types of circuits. That also we'll see. So in state diagram, a state, every particular state is represented by a circle. So what is one thing important here is a circle. The transition between those states will be indicated by directed lines, commonly known as arcs. Okay, commonly known as arcs, which will be connecting the circles, and they are directed lines. Directed lines means they'll also be showing the flow of the signal, the flow of the change of state, from which state to which state you are moving ahead, right? So let's start discussing one by one. Let us start by SR flip-flop actually. Let us start by the SR flip-flop actually. Okay. Let us start by the SR flip-flop actually. Now in the SR flip-flop, what was the characteristic equation? What was the characteristic equation? Let us review. The characteristic equation was Q plus is equal to S plus R bar Q with the condition SR should be 0. The product SR equal to 0, you know, just ensures that one of the variable S or R is always 0. Both cannot be 1 at the same time, otherwise the flip-flop goes into the invalid state. Right. Now sir, what was the characteristic table? A quick review, right? What was the characteristic table? So in the characteristic tables, I take both the variables SR and then I take the next state. I just show the relations between SR and the next state. If the SR is 0, 0, the next state remains the same. Q plus equal to Q. It is the same state condition. S1 R0. S1, S stands for set. S1 R0 corresponds to set state. S0 R1 corresponds to reset state. If S is 0, R is 1, R high, R is for reset, and that will reset the latch. 1, 1 is invalid state. Okay, and the problem of invalid state anyways we have identified. Now, I would like to trace state diagram, state transition diagram, in short known as the state diagram. So what should be the state diagram for SR flip-flop? See, very simple philosophy we have to keep, right? As I told you, in a state diagram, every state is represented by a circle. So we are talking about one flip-flop right now, SR flip-flop, and that flip-flop can be in two states, either 0 or 1, reset or set. So how many types of states can be there? Either the output can be in 0 state or either the output can be in the 1 state, right? Either it can be in the 0 state or it can be in the 1 state. Okay, so have a look into this, right? I take one circle, every state is represented by a circle. So this is known as the reset state. This is known as the set state. And then we have directed lines which are connecting the circles. And then we have what? Then we have directed lines which are connecting the circles. Now, the state transition will depend on the value of the input as well. Na? So if input is 0, 0, I will remain in the same state, whatever may be the state. If it is 0, I will be in 0. If it is 1, I will be in the 1. So look at this now very carefully. I make a directed arc from Q equal to 0 up to Q equal to 0 whenever the input is 0, 0. Dhyan dena. Now input is written over the directed line. Input is commonly written. Okay, here it is a 2-bit input actually combining S and R. So if the input is 0, 0, I remain in the same state, and that happens here also. That happens here also. If the input is 0, 0, remain in the same state. Right, if you are reset, you will be reset. If you are set, you will remain in the set state. Acha. If the input is 1, 0, sir, then the device should be set. Then the device should be set. So let's start with this case. Right now the device is reset, but if the input comes to be 1, 0, the device will set. The device will set. So make a transition from reset to set. But we have to show the state transition from all the states. So suppose I am already in the set state. I am already in the set state and I get the input as 1 0, then what will I do? I get the input as 1 0, then what I will do? I will again be set. Matlab I will again be remaining in the same state. So I am into set state, 1 0 also set state, so remain there only. So remain there only. That means try to understand. I can draw one more arrow like this and write down 1 0, but this is not usually done. It is the same type of transition as I draw earlier. So whenever you have the same type of transition, what will you do? You will not make a different arc. You will not be making a different arc. Over the same arc, just place a comma and write down 1 0. Just place a comma and write down 1 0. What is the meaning of this? Ki whether the input is 0 0 or 1 0. For both of the possibility, I get the same result. Okay. Now, what is the next input? 0 1. S0 R1. Right, S0 R1 is reset state, so device will be reset. So let us start with this. Here, the device is already reset. If I apply the input 0 1, it will still be reset. It will still be reset, means it remains in the similar state. So comma karke. No need to make another similar arrow, na? So just write down over the same arrow by placing the comma. Right? Okay. But as I told you, you have to show the state transition from every possible state. So if the state is 1, and you have to make a transition, if the state is 1, the input is 0 1. Try to understand. The flip-flop is set, but if the input is 0 1, the flip-flop should next become reset. So from set to reset state, if the input is 0 1. Okay. Now, if the input is 1 1, it is known as invalid state. So what I told for input 1 1, I explained you clearly what is the problem of invalid state, why it is invalid, what harm it can cause to the device, why it is dangerous. And I told you eventually, because it is a dangerous condition, the user must take care not to apply the input 1 1. Not to apply both SR high. So this is a type of input combination which does not occur, and hence it is not shown in the state diagram. And hence it is not represented in the state diagram, because user should not apply the input, so no need to show for the state transition corresponding to 1 1. So this is the complete state diagram for the SR flip-flop. This is the complete state diagram for the SR flip-flop. Right. Chalo, so by this motive, let us write down the state diagram of all the flip-flops, and then let's go towards some question practice, some different type of circuits we'll take. So now let us take the D flip-flop in sequence. Let us draw the state diagrams of all 4, right? So let's have a quick review first of all. For D flip-flop, what is the characteristic equation? In short, I will write, what is the characteristic equation? It is simply Q plus equal to D, right? And what is the characteristic table? What is the characteristic table? Right, Q plus is D. So if D is 0, Q plus is 0. If D is 1, Q plus is also known as 1. That's it. That is what is the simple characteristic table I am writing. Q plus is directly equal to the D. Now, the same thing we want to represent with the help of a state transition diagram. With the help of a state diagram. So what will I show with the help of state diagram, guys? What will I show with the help of state diagram? To try to understand. Okay, once again, the flip-flop, every flip-flop can be 2 different states, 0 or 1, reset or set, and for every state you have to draw a circle. Okay, now the input is D here. If the input is 0, the next state will also be 0, right? So if the input is 0, the next state will also be 0, means you will remain in 0 because you are already in 0. But if the input is 1, I am starting with the reset first. The device is reset, but the input is 1, so Q plus will also be 1. So next state will be 1. So if you are in the current state 0, if you are in the current state of 0, and if the input comes to be 1, the device will go into the set state. Now come to this state, guys. Suppose now you are initially into set state. Look into input. Input 0, next state will be 0. Input 0, next state will be 0. So I make the flip-flop go to the next state, which is 0, which is the reset state if the input is 0. What I am writing on the lines, I clearly told you that is the input. Right. Now I am in the set state and the input comes 1. So next state is also 1. Next state is also 1. So remain here only. You are already in 1. So remain here. That's it. That is the DFlip Flop state diagram finished. That is the DFlip Flop state diagram finished. Okay. So guys, tomorrow, as I told you, we have this, tomorrow, as I told you, we have what? The waveform based questions, which are actually very important for gate, which are actually very, very important for the gate. The state, the waveform based questions, some good questions, but till yesterday also it is still acceptable. But today's class attendance is very low, and if the students are not regular, maybe they are studying something else, or maybe they are busy with IPL, I don't know, whatever. If the students are not interested, I should not be taking these classes. Then YouTube, why to make it just free available when the students are not much interested, right? I can stop right now also, but for the sake of some students, see, even if very few students are live, I respect them, and for the sake of those students, I will not stop any session in between. I will continue this. If those who are there to learn state diagrams, I will complete this, right? But mostly I will not take tomorrow's class. That is very much clear, because we keep taking, there is no commitment from the student side. There is no commitment from the student side, right? And there is no commitment. If there is no requirement, no problem, right? Man to aisa kar raha hai ki let me stop right now only. But again I say, okay, even if those who want to learn right now and they have just stay tuned for my class at 8 p.m. I cannot disappoint them. I respect their presence and I will complete now. But tomorrow, then in such a scenario, tomorrow there is no point, na? Chalo. Now let us quickly go to the DFlip Flop. Let us what? Quickly go to the DFlip Flop. Oh sorry, D is done, na? Oh, sorry. Now we'll be going towards the JK flip flop. Right. Let us go towards the JK flip flop. A quick review quickly. Right. What is the characteristic equation? Q plus equal to the JQ bar plus K bar Q, right? And what is the characteristic table? Let me draw that quickly. Based on the JK value, what will be the next value? What will be the next state, right? What will be the next state? Now if JK is 0, 0, we know that device remains in the same state. Whenever the input is 0, 0, device remains in the same state. Yes, Navneet, cool, that's great. Okay, whenever the input is 0, 1, J0, K1, if J0, K1, the device remains in reset state. J0, K1 corresponds to reset state. J1, K0, if J1, K0, device set state. J1, K1, both 1, 1. So that is known as the toggle state. That is known as the complement state. So the state gets complemented, Q bar, it becomes the Q bar, right? Now, based on this information, let us make the state diagram. Based on this information, let us make the state diagram. Let us simply make the state diagram. So we have Q equal to 0. We have Q equal to 1. We have the Q equal to 0. We have the Q equal to 1. Right. Now look at the input. If the input is 0, 0, if both the JK inputs are 0, 0, device remains in the same state. Same state means if it is reset, will be reset. Ye likh diya input 0, 0. If it is set, will be set. Here I write input 0, 0. So for the 0, 0, you remain to be in the same state. Now, if the input is 0, 1, the device should be reset. So if I start from this state, this is already reset. If the input is 0, 1, it should be reset. It should be reset. So means it should be 0, 1. It should remain in the same state. But if I start with set, and if I see the input 0, 1, device should be reset. Device should be reset to make the transition go here. Make that transition go here. If the input is 0, 1, make the transition to the reset state. Okay. Now coming to the input, which is the 1, 0. Now coming to the input, that is known as the 1 0. So if the input is 1 0, device should be set. So if I am in the 0 state, if I am in the reset state, if the input comes to be 1 0, if the input comes to be 1 0, the device will set. Okay, so it will go to the set state. But if I am already in the set state and if the input comes to be 1 0, the device will be set only. So I am already set. I will remain in the set state. I will remain in the set state. Matlab same transition will be shown. So write down the input by putting a comma. No need to make the arc again. No need to repeat the arc. Last but not the least, if the input is 1 1, the device should toggle. If the input is 1 1, the device should toggle. That means if the device is in reset state, it should become set. Or if it is set state, it should become reset. Matlab transition from one state to another. So already one transition has been shown. Over the same transition, just write down one more input by placing the comma as always. This is the state transition diagram of the JK flip-flop, hence completed. This is the state transition diagram of the JK flip-flop, hence completed. Okay. Chalo, done. Last one, what is left here is, the last one is T flip-flop, and then we take miscellaneous question. What about a T flip-flop, sir? Okay, so first the quick review of whatever we have studied for the T flip-flop. The characteristic equation Q plus is Q XOR T, right? The characteristic table, the functionality, that is what is important, we know, right? T and Q plus. We know that T equal to 1, T known as the toggle input. So whenever T is high, the device toggles. Whenever T is 0, the device remains in the same state. No change. No change. Now finally making the state diagram just based on this. Q equal to 0, Q equal to 1. Q equal to 0, Q equal to 1. Q equal to 0, Q equal to 1. Right. Now, whenever the input is 0, device should remain in the same state. It should remain in the same state. Same state means reset to reset and set to set. Whenever the input is 1, the set should toggle, the set should complement. So if I am in reset, I will go to the set state if the input is 1. Or if I am in the set, I will go to the reset state if the input is 1. Finished. Very simple. Drawing it for T flip-flop is very simple. This is the state diagram of the T flip-flop. Okay. Now guys, if this is understood, let us take a question here, which is a gate 2-mark question. Okay. Let us simply take this question, which is a gate 2-mark question. The state transition diagram for the logic circuit shown below will be. What will be the state transition diagram for the logic circuit shown below? The gate 2012 2-mark question it is. The state transition diagram for the logic circuit shown below. Come on. So now I have a D flip-flop mixed with a multiplexer. A D flip-flop combined with a multiplexer. A D flip-flop combined with a multiplexer. Come on. Yes, start solving it. So now I hope everybody remembers the functionality of the multiplexer. The select line is known as the A, right? Here we have what? Here we have a 2 cross 1, also known as a 2:1 mux, right? The select line is A, right? If A is equal to 0, if the select line A is equal to 0, right? What is the output of the multiplexer? The output Y is taken from the data line, the input line, which is the X0, right? Just a quick review of the multiplexer. If the A is equal to 1, the output of the multiplexer corresponds to the data line x1. Okay, so any one of the two inputs is transferred to the output line with the help of select line. The select line, also known as control line, which will control which input is connected to the output at that particular moment. Right? Okay? At that particular moment. Acha ji. Okay? Chalo. Now, basis of this, we need to draw the state diagram of the entire circuit, keeping the input as A. It is very clear in the options that the input to be taken as A, and we have to show the state transition, not the multiplexer output. We have to show what is the next state. Acha. So, what is the next state for DFlip flop? It is actually based on the DFlip flop, na? It is actually based on the DFlip flop. So, for the DFlip flop, what is the next state? Next state, Q plus is equal to D. Now, what is coming to the D input? The D is actually connected to the output of the multiplexer. The D is actually connected to the output of the multiplexer. Now, what is the output of the multiplexer? It may be X0 or X1 depending on the input. So, this may be equal to X0, right? This may be equal to X0, right? If A is equal to 0, and that may be equal to X1 if the A is equal to 1. Now further, what is X0 and X1? Sir, what is the value of X0? What is the value of X1? So X0 is connected to the Q bar, X1 is connected to the Q. A very simple observation that you can make here, right? Okay. Right. So the X0 is equal to Q bar, X1 is equal to the Q. So in short, I can write down, let us skip all the intermediate variables. Finally, I can say that Q plus is equal to Q bar if the input is 0, Q plus equal to Q if the input is 1. Yeah, if you want, we can write this information in the form of the characteristic table. We can write down this information in the form of characteristic table and then draw the state diagram. So what is the characteristic table? Suppose they can ask you the characteristic table also, right? So what is the characteristic table here? Based on the functionality of the circuit, what is the characteristic table? Right. The input A and the next state Q plus I want to write. Input can be 0 or 1. If the input is 0, the next state Q plus is equal to Q bar, complement, right? If the input is 1, Q plus will be equal to Q. So that means I can simply say that this flip flop is working just opposite of T flip flop, opposite of the toggle flip flop, right? If the input is 0, then toggle. If the input is 1, then remain in the same state, just opposite of the toggle flip flop. So what is my state transition diagram? We can look into the options also, but yeah, now we are comfortable in drawing the state transition diagram quickly without referring to anything. If the input is 0, toggle. Toggle means 0 ka hua 1 or 1 ka hua 0. So if the input is 0, toggle. If the input is 1, remain in the same state. If the input is 1, remain in the same state. If the input is 1, remain in the same state. That's it. So let us see what is the option that is correct. What is the option that is correct? Yes, clearly it is the D option. If the input is 1, remain in the state. If the input is 0, toggle it. The input is 0, toggle it. So correct answer is option number D, hence marked. The correct answer is option number D, which is marked in front of you, right? Chalo. Moving to the next question here. Yes. Come on all. Take up this next question. Consider the following state diagram. Now a state diagram is given. This is a little different and reverse question. Consider the following state diagram and its realization by a JK flip-flop and its implementation by a JK flip-flop. So see, what was given in the previous question? A particular flip-flop, like previous question, a D flip-flop mixed with a combinational circuit like multiplexer was given, and they were asking you to draw the state diagram. Now a state diagram is given, right, which is to be realized by a JK flip-flop. What is the combinational circuit that generates J and K? That generates J and K. Like if you see the previous question, the combinational circuit was multiplexer. The output of the multiplexer was generating the D input. Here the output of the combinational circuit is producing the JK input. So the combinational circuit, when it take the input as X, Y and Q, okay, what should be the combinational circuit inside? The combinational circuit JK generates JK in terms of X, Y, Q. What is the Boolean expression for JK? Because the output of the combinational circuit is JK. Once you get that expression, you will be able to say what is the combinational circuit. What does the combinational circuit contains? Like the previous one was containing the multiplexer. Come on all, can you tell me? Let's start solving it. Okay, so let us make this state transition diagram into the state transition table, simply known as what? Simply known as the characteristic table. Everybody, let us just quickly draw the characteristic table of this one. Look into the state diagram and draw the characteristic table, and just allow me. Yes guys, so let's check it up. What is there inside the combinational circuit? Okay, so what is the characteristic table? What is the characteristic table? The input, okay, based on the input, whenever the input is 0 0 or 1 1, the device should remain in the same state. The device should remain in the same state. That is what is one of the case. Okay, that is what is one of the case. Correct. That is what is one of the case. तो यहाँ पे लिख देते हैं. Right, whenever the input X, Y, the input means the input here is X, Y, it is clearly seen in the circuit. Whenever the input is 0 0, 1 by 1 लेंगे तो 0 0, both the arrows reflect that, reset to reset, set to set, मतलब same state, Q plus should be Q. When the input is 0 1, now let us read the 0 1. This is the 0 1 guys. Whenever the input is 0 1, the device is changing the state, मतलब toggling the state, 0 ka 1 and 1 ka 0, it toggles. Whenever the input is 1 0, then sir, yes, even at the 1 0, it toggles. Whenever the input is 1 0, 0 converted to 1, 1 converted to toggle. That is what is inversion. That is what is the toggling, right? So even at 1 0, the device toggles. Last possible input combination is 1 1. So what happens at 1 1? What happens at 1 1? So look at the 1 1. The device, if 0 remains to be 0, if 1 remains to be 1, means same state. Means same state. So Q plus is equal to Q. The Q plus remains equal to the Q, right? So this is completed simply. Okay, now based on this, this combinational circuit which takes the input X, Y and Q produces the output JK. What is that expression for JK? So what you have to do now, right? We know the state transitions now. Q plus equal to Q or Q plus equal to Q bar. Okay, what should be excitation table सोचना है आपको. Like yesterday I explained you know excitation table. For a given state transition, what should be the input to the flip flop? Reverse you have to think. For the given state transition, what should be the input to the flip flop? The excitation table actually you have to make, right? The excitation signal. So this is the excitation part. What input to be applied to make that state change occur? To make that state change occur, right? So Q plus equal to Q, same state occurs for when JK is 0 0. Q plus equal to Q bar, toggle occurs when JK is 1 1. Q plus equal to Q bar, again 1 1. Q plus equal to Q, same state condition when the input is 0 0. When the input is 0 0. Right? That is what is the excitation variable coming up here. That is what is the excitation variable coming up here. Now what should be the Boolean expression for J and K? Array, now it is a very simple process guys. What should be J and K on the basis of this? Right, J is high at 0 1 1 0, XOR bait possibility when both the bits are different, and even K following the same pattern as J. So what is J? XOR of X and Y. What is K? K is also XOR of X and Y. K is also XOR of X and Y. So both are X XOR Y. So correct answer is option number A. It's not C or D, it's option number A. The correct answer to the question is clearly option number A, everybody. Got it? This is the reverse. State diagram is given. What should be the combinational circuit along with the JK flip flop to implement that state diagram? To implement that particular state diagram. Okay. Chalo. All cool. Yes guys, a quick reminder once again that a quick reminder again that tonight in some time at 10 p.m. on the same channel where you're watching this session, so do not forget to subscribe the channel in case you haven't subscribed, so that all technical sessions, all informative sessions, all general guidance sessions like this, very soon will bring you maths and aptitude sessions also. All these sessions you can attend without a miss. All these sessions you can attend without a miss. So how to deal with stress and anxiety in the digital age, right? एक second, why? Just let me check. X XOR Y we've all solved, na Sai Charan? Yeah, just a second. Let me go to the previous. Okay, got it. We solved X XOR Y only. I think I marked something else. It's D only. Correct, Sai Charan. Thanks for it. X XOR Y. We are clearly able to solve that only. X XOR Y. Maybe I just marked it wrong. It is X XOR Y and X XOR Y. Option number D. Correct, guys. Okay. That is very much correct. No problem there. No issues in that. Okay. Chalo guys. So let's connect again at 10 p.m. tonight. Okay. To discuss this important issue and what are some scientifically proven solution to it. See, we can't stop our studies. Okay, we can't stop the education, we can't stop the online studies, we can't stop the gate preparation, but at the same time we can't compromise with the help. So what are some of the scientifically proven techniques? Okay, some of them may be difficult, but yes, if you adopt them, yes, you will be able to adapt the digital world without making any compromise in your health. So what are those techniques? Let's discuss in this session at 10 p.m. to share it to all of your friends. That can be of any branch. This session is useful for any student of any branch. Okay, not only for electronics or electrical. Yes, guys. And this is what the next class, let's see what happens. Okay, guys. So that's it for the session. Stay connected and do not forget to subscribe the channel in case if you haven't subscribed. Okay, with this, Rakesh Talreja will sign off for the class. Bye bye. Thank you. Stay safe and take care. Yes, Surendra, sure. So just once I have shared my Telegram link. That is actually my alternate Telegram. My main Telegram, some issue is there, and hopefully it resolves quickly. By that time we have an alternate Telegram where you can discuss your queries and where you will get the session informations and the PDFs, right? Okay guys, bye bye. Thank you. Stay safe and take care of yourself.